All right, this is our second video for section 5.5, and here we're going to look at how we can now solve equations using the method of completing the square, okay? Now, I want to stress this. This method will work to solve any quadratic equation, okay? But as you're going to see with some of our examples, it can get a little messy, okay? So there's kind of an order to the methods that you should try. I would always begin by trying to solve by factoring first, and then if factoring doesn't work, I would maybe try to move on to completing the square, okay? Now, remember, completing the square is a process used to make a perfect square trinomial, okay? So if you look at the example here in A, the equation is x squared plus 4x minus 12 equal to 0. I can tell right away that that is not a perfect square trinomial on the left side, simply because that constant is not a perfect square, okay? So I'm actually going to begin this process by moving that over to the other side. And in doing so, I'm going to set up a couple blanks on each side. So if I move it over to the other side, it becomes a 12. And then I put in a plus blank on each side because this is going to be where I'm going to place the number that turns the left side into a perfect square trinomial. And then since this is an equation, if I add a number on the left side, I have to also add it on the right side to maintain balance in the equation, okay? So now you use the process of completing the square to make that perfect square trinomial, okay? Your b value here would be this value of 4. So you're going to cut that in half. That's going to give you 2. And then you're going to square, which is going to give you 4. So I'm going to put a 4 in each of these spots, okay? Now the left side is a perfect square trinomial that factors to x plus 2 times x plus 2, or that's x plus 2 squared equal to 16. And now I'm in that spot where I can use the square root property on both sides here, okay? And I'll say that x plus 2 is now equal to plus or minus 4. I'll subtract 2 from both sides to get x alone. And I can say that x equals negative 2 plus or minus 4, which can then be simplified. Negative 2 plus 4 is, of course, 2. Negative 2 minus 4 is negative 6. So there are my two solutions. Okay. All right, let's use the same approach for part B here. X squared minus 6 is equal to 35. So it's presented a little bit differently than the previous problem. If I were to set this equal to 0 by subtracting the 35 over, I wouldn't have a perfect square trinomial, okay? So I actually like that the 35 is already over on the right-hand side here. So I'm going to make this just x squared minus 6x plus blank equals 35 plus blank. So I'm going to go immediately to setting up those blanks to be able to complete the square, okay? So in this case, my b value is negative 6. So I'm going to cut that in half to give me negative 3, and then I square that. That's going to give me 9. So 9 is the number that goes into each blank. The left side's now a perfect square trinomial. It factors to x minus 3 squared. And then 35 plus 9 is, of course, 44. Now I can use the square root property on both sides here. That'll lead me to x minus 3 is equal to plus or minus 2 square root of 11. Okay, 44 is 4 times 11, and of course, square root of 4 is 2. Then you can add 3 to both sides. and x would equal 3 plus or minus 2 square root of 11, which if you want to stay exact, you can't really simplify any further than that. So your two answers are 3 plus 2 square root of 11 and 3 minus 2 square root of 11. And I'm just going to leave them combined like this. Okay. All right, so both of those equations were pretty perfect for completing the square because the b values of each of the equations were both even numbers. Makes the process of completing the square very easy. So, you know, these again are perfect for that, okay? Go to practice 3, try it yourself, and then come back, check your work with mine. All right, I want to cover one final example here. And this is a very important example for the method of completing the square, okay? What I want you to notice is that your a value here is not 1, okay? And that is a problem for the process of completing the square. We always want that first term to be 1x squared when we're using this particular method, okay? So the first thing I absolutely must do if I'm going to use this method is I need to divide out that coefficient from both sides of the equation, all right? And it's going to make the equation maybe seem a little more complex to us because a lot of times this first step leads you to fractions, okay? So in this case, we end up with x squared minus 2/3 x plus 4/3 equals 0, all right? Now don't let the fractions scare you off here, okay? We can work with these, all right? This is not a perfect square trinomial, so I'm going to move the 4/3. I'm going to subtract it over to the other side, and I'm going to set up my blanks for completing the square. So notice once I subtract that over, it's now negative 4/3. Okay. Your b value here is negative 2/3. All right, so first thing to do to complete the square is you're going to cut that in half. All right. Now, here's my suggestion. If b is already a fraction, when you go to divide it by 2, just think of it as being multiplied by 1/2, okay? Negative 2/3 times 1/2 is going to become negative 2/6, which reduces to negative 1/3, okay? Then you're going to square that, and squaring a fraction, again, just means square the numerator and square the denominator, so you'll end up with 1/9, okay? So I'm going to add in 1/9 to each side of the equation, and now the left side is a perfect square trinomial, okay? It's going to factor to x minus 1/3 squared. Remember, the b over 2 value is always going to go in this spot right here, okay? Now on the right side, I have to add negative 4/3 with 1/9. So the negative 4/3, you need to think of that as having a denominator of 9. So that's going to change the negative 4 to a negative 12. Okay, so negative 4/3 becomes negative 12/9. And if I add that with 1/9, I'm going to end up with negative 11/9. Okay. Now I can use the square root property on both sides here. X minus 1/3 is equal to, I'll say that this is plus or minus I squared of 11 over 3. Okay. So that ends up giving you an imaginary number, of course. And then I'm going to add 1/3 to both sides to get x alone. And there's two ways you could write this. So you could say x equals 1/3 plus or minus I squared of 11 over 3. Or notice how both the real number part and the imaginary part, they have the same denominator. So it's very common for us to combine these together and write it as 1 plus or minus I squared of 11 all over 3. Okay. It doesn't matter to me which way you write it. Either's okay. Okay. All right, so move to practice 4, and that one should require the same first step as what we did here in dividing out this a value of 3. Okay, so make sure you do that first, and then follow the exact same process, that we've done in the rest of this problem. Okay, try it yourself and check your work with mine.